Okay, hi and welcome to another session of linear algebra with Kabir. Okay. Uh, After we have learned the indexing in one-dimensional array and two-dimensional array, it has come to a sense that would it be possible to slice an a portion of the array and bring it out to the output? Let's see how we do that. Okay. First thing you have to do is create an array by putting a list in the array function from the ordinary numpy and pour it in the variable called data. Now this is the important one. If you want all the data to be shown, just put a column, okay? But if you want like from zero from the zero index to the one element. But let me say this: when you say one over here, when you put one over here, it doesn't mean this. It uh, it will exclude 22. So what this will show is number 11. Okay, keep that in mind. And this number minus 2 to the end is it's implying that the minus 2, this is minus 1, this is minus 2, it will show this until the end. Put in mind that if I don't put anything over here, it will just go to the end no matter what. It's not like the upper one that it will exclude the one that is over here. It will just go to the end. Okay, just keep it in mind. Let's run this. Okay, this is the first print, and it printed all the elements, and this is the second print. As I've told you, the 22 will be excluded and the 11 will be shown. Okay, and 44 and 55 is shown respectively, and this is the slicing. Yeah, it's not that complicated or anything. Now let's go to the two-dimensional slicing. Okay, it's kind of like the one-dimensional, but it will go like the row. It will slice the row and the column. Okay, it's the row and column is separated by a comma, and you just what I did was I created an ND array, a 2D array, and I put all the rows. I selected all the rows, and I selected all the columns except the last column. Okay, this -1 is 33, 66, and 99 column that it will be excluded. This the second one, the second parameter will not be included. If you didn't put anything over here, then it will go until the end. Just let's clear this up. And the second thing I sliced was I selected all the rows and I selected the last column. So what will we want to see if we print x and y, or let's say array 1 and array 2. What we want to see is that array 1 is 11, 44, 77, and second column 22, 55, and 88. And what we want to see for array 2, which is this slicing, is the last column, but all the rows is 33, 66, and 99. Okay, let's run this bad boy and we see the result. Yep, as we expected. But as you can see, the last column is shown like a row, but let's just say that this means one column and all the rows is like the shape. Let's print the shape dot shape. It's 3 rows and 1 column. You just put it in your mind and visualize it so that you will understand what I'm saying. Okay. Okay, the second thing is that when we want to, okay, let's say we got the data and we want to train and test split it. I mean that you got the data and you want to put a majority of the proportion in the training data and the lesser proportion, which is a holdout, I think, the 20% of the proportion of the whole proportion we want to put it in the test data. What you can do is that you can slice the array. Okay, you can slice it in a way that we just put the split to 2. Okay, and it will just go all the rows until the second, which means this row and this row, 44 and 11. We want this row and all the columns, and the test data, we want the last row as the test data. Okay, you see it presents like this. These rows are observations of what do you call it? Experiment. These 3 rows are the observation of an experiment. The first row is the first observation, the second one is the second, and the third one is the third observation. What you want to do is that you want to put these 2 observations in the training data set and the last one in the test data set. You can do it like this. And when we print this, as you can see, the training data is these 2 rows and test data is 77, 88, and 99. Okay, I hope this clears everything up. The next thing I want to teach is that you can reshape an array. This is very important because in a lot of libraries of machine learning or computer vision, they need a specific shape of an array. Okay, if that shape is not created, you cannot pass in the data to the machine learning algorithm. So it's very important that you know that arrays can be reshaped. Okay, and the way it can be reshaped is like this. First of all, we need to know the data shape. NumPy arrays have a shape attribute that returns a tuple of the length of each dimension of the array. For example, this is the one-dimension array, and when you just print a shape, data.shape, you'll say 5 rows and 1 column. Okay, and the second one is a 2-dimensional array, and when we run the shape attribute, we'll say 3 rows, as you can see, and 2 columns. And we can access the row and the column individually by just putting the brackets and the first or you can say the 0th element is the row, the number of rows, and the 1st element is the number of columns. And just print it. Yep, and this is 3 and 2. 3 rows, 2 columns. Okay, let's end this session. I think the session will become very long if I go on. And yeah, let's end this. If you guys don't know me, I am a data scientist in specialized in machine learning and computer vision. This is my GitHub, Kaveh Karimadini, and the repository for this course is LA NumPy Masterclass. Okay, thank you and goodbye till the next session.